Okay, the next one is a little simpler. We can move the exponent to the front, and I'll have x log 2 of 4. So that's x times 2. So it would be just 2x. So I'll let you try a couple others again. Actually, these ones are kind of strange. Maybe I'll do the first one with you. When you get questions that say write in terms of, that means that's the only thing you should see in your question. So for example, I don't have log m, I don't have log n, I have log of this whole thing right here, which is kind of a mess. So what I'm trying to do is get rid of everything in terms of the logs except for log m and log n. So for example, one thing I can do is I can expand this out. Okay. And then I can try and get rid of everything except for, let's see here. I can get rid of this as a 3. And I don't want log m squared, all I want is log m. So I can rewrite this as 2 log m plus log n. And at this point, there's nothing else that I can do to simplify it. The only logs which appear in my answer are the 2 up here. Okay, so see if you can do the same thing in this example for part B. Okay, can I just see, we've finished this one? You've worked it out? Excellent, okay. So to separate these, n to the 4 minus log 10 of m squared, and this would be 4 log n minus, well, this time we have to be careful when we separate it, because I'm subtracting the whole expression here. So even though it would be log 10 plus the log m squared, when I expand it, it's actually going to become negative. Okay, so be careful. It's because of that extra subtraction that it ends up being the net result is subtraction. So the last thing I can do here, this is a 1, and I can move 2 to the front. So this would be 4 log n minus 1 minus 2 log m. And at that point, I have everything down to just log m and n. Okay. So be careful of that. One thing that I usually tell the grade 12 students is when it's on the bottom of the fraction, it's going to be subtracted. So if you had 10 things on the bottom, you could expand it in the one step by subtracting all 10 things. If you had 10 things on the top, they would all be added. So you can, that's a safe rule for you to know. If it's on the top, it's going to be added. If it's on the bottom, the end result is going to be that it's subtracted. Okay. So if the natural log of some value a equals 2 and the natural log of b equals 3, what is the natural log of a over b squared, the natural log of ab squared? So I get negative 4 for this first example. In the second example, basically the only reason that's there, it's not super difficult to do, but I'll show you one of the common mistakes that students make with this question. If I do this, it's going to be 2 plus 3 squared, so 5 squared is 25. So one of the common mistakes that students make is they mistakenly move that exponent to the front. That's not the same thing as the natural log of ab squared, because it's saying do the work in the brackets first and square it. Right? They're not the same. So the only reason that's there is to bring it to your attention. You can't move that exponent to the front just yet the way it's written.
Excuse me?
Yes?
What was the natural log again?
Natural log is the log in base e, which is Euler's constant. the other one you find on your calculator. Natural log and the log in base 10 or the common log.
So what does natural log of A equals to 2?
Well, that would be e squared, Euler squared. So it's just saying that there's some number. They're not telling you what the number is. They're just saying, I have a number. Its natural log is 2. In fact, that number would have to be e squared, which is Euler's constant squared. So if you look on your calculator, you can put it in. It's something like this that just keeps going on and on and on. Okay, so last one. Oh, sorry, I lied. There's 2 more. Okay, given that log base 2 of A equals 5, evaluate this. So you have to rework the log laws to try to figure out what the actual value of this expression is. So I'll try to catch up if you're not quite finished yet. One thing that I can do here is I can start by separating these like this using the multiplication rule. I can't move the exponent to the front because the exponent only applies to one of the values, not both. So I can only use the multiplication rule right now. At this stage, right here, the exponent is to everything in the logarithm. So now I can move it to the front. So this will be 2 plus 2 log base 2 of A. And that one's been given to me as a 5. So this would be 2 plus 2 times 5. So we would end up with 12. Okay, so this time log base x of 3 equals to A and log base x of 25 equals 5. Can you figure out a way or a clever way to end up with the log base x of 9 over 5? Okay, so those of you who've been, as I walked around, I noticed that you're trying to connect the 5 and the 25, right? And you're correct in thinking that you want to take a square root. But what we really would like to see is the log base x, that's 5 squared. That's the way I want to think of it in order to get a 5 in my answer. So that means I would need to move it in front. So this would be 2 log x to the 5. And these are all still equal to what it was before. So that means if I want to know what's the log base x of 5, well, it's actually going to be half of b. Why is it half? Because half is the square root. That's the exponent you were looking for. So if I want to divide this expression, it's going to be log x of 9 minus log x of 5. Same thing is going to have to happen with log x of 9. This will be log x. This will be 9 to the 1/2. So then I end up with 1/2 log x of 9. So log x of 9 equals 2a's. Why is it 2? Well, to get from 3 to 9, the exponent is 2. You have to square it. Okay. So this would be 2a's minus a half b. Why is 2 log x5 equal to b? Well, do you understand this part here that I can rewrite log x of 25 as log x of 5 squared? So you agree that these two are equal? You agree? So then I can move the exponent, like I did here, to the front. And that's how I get this next step, still equal to b. Then if I solve this, I'm looking to figure out this because that's what I have over here. So that's why I divided both sides by 2 and I ended up with b over 2. Same process on the other side, but instead I'm changing it into 9s.